here's a polynomial. And we try to graph this polynomial. I didn't see on the homework I looked at last night much about the far left and far right behavior that we talked about. So make sure you pick up on that. I'm going to mention it here, but I'm not going to explain it. You know, you go out that way a long ways, you go up that way, humongous way, you got to go up that way. It's going to do this, right? Okay? Okay, so I'll tell you a little more about how to graph these things and then maybe extend it to things we can do for rational functions. So we have zeros at 3, 7, and -5. Make sure you check these out, because it's really easy, like to write down zeros at 5 and -3 and -7. When you look at this, if you look at it without thinking, right? You think, okay, if I put in 5, would I get 0? No. If I put in 5, I don't get 0, right? I've got to put in -5 to get 0. Okay? So you got to be aware of that. That's one little thing I saw in a couple of papers, which otherwise looked pretty good, but you don't want to make that mistake. Okay? Okay. So we have zeros here. We have a y-intercept that's easy to calculate. Let x equal 0. 3 times 5 is 15. 15 times 7 is 105. And you got 2 negatives and a positive, so it's going to be positive. So we have 105 here. Now, if we go far to the right, all these x's are going to be big positive numbers. You're going to have 3 big positive numbers that you multiply together to get a humongous positive number. Okay? So it's going to go up this way. On the left, you're going to have big negative numbers. 3 big negative numbers give you a humongous negative number. It's going to go down this way. So after you pass this last 0, it's going to tend to go up very steeply. And after you pass the last 0 going this way, it's going to do that too. Okay? So we know that the function is going to have a graph that does something like this. Right? Okay, well, let's take another one. And let's just, I'm going to do a polynomial divided by a polynomial. I'm not going to actually construct a graph of this thing, because there's a little more to it if you have a polynomial divided by a polynomial. Okay? And we'll be talking about that soon. But let's say you got this. And that's not a polynomial, that's a rational function. We often use Q for ratios. Okay. So we're going to call that Q of x. Now, you know some things about this graph. You know it's going to have zeros at 4 and -5 and -2. Because if you make any of these terms in the numerator 0, the whole thing's going to be 0. Unless the denominator has a term that matches it, right? If I had an x plus 2 here, I'd have an x plus 2 here, right? And we're not talking about that case. We're talking about that case when we do the whole thing. Okay? But what we can say is that at x equals 4 and at x equals -2 and x equals -5, the graph has to go through the x-axis, right? Okay? Another thing is, and we're going to use the principle that we've used for a long time, although I'm not sure everybody's really thinking about it. You can't extend the graph across a value of x where the function is undefined. Okay? So I can say that, well, if x equals 3, this thing is undefined, because that's going to give you a 0 in the denominator, and 0 division by 0 is not defined. Okay, so at -3, I'm going to draw a dotted line here. I'm going to say that the graph can't cross that dotted line. Okay? It can't cross the dotted line because the dotted line indicates x values where the function is not defined. Its domain doesn't include x equals, I did it. If x is -3, that denominator is not 0, is it? Okay, well, it is now. Okay. Okay, see how easy it is to do that? That's why I say, keep your mind focused like I did. Okay, so we have that. And I'm going to go ahead and make that x minus 4. Okay? So that at x equals 7, well, it's going to be the same thing. We shall not cross this line or this line, right? We've got a graph on this side, we've got a graph on between, and we've got a graph on this side. But it could be three completely different looking curves. Okay? And it's actually kind of complicated in this case. Okay, well, we know that. What if x is a big positive number? What do you have? Well, you've got 3 big positive numbers in the numerator and 2 big positive numbers in the denominator, right? Well, a big positive divided by a big positive just gives you a regular old number, not big, okay? And a big positive here divided by a big positive here gives you a regular old big number. But it leaves you with a big positive number here, right? But it's not humongous, because these are just regular numbers, okay? The only thing that doesn't give you just a regular old garden variety number is this one. So this thing goes up, okay? But it goes up kind of like this. Not really, it doesn't get steeper and steeper, okay? And we'll see why. And we can figure that out by long division and all kinds of other things. But it is going to be positive. And if x is a big negative number, then what you got is 3 big negatives divided by 2 big negatives. Now, is that going to be positive or negative? Well, how many negative numbers do you have there? Give you a hint. You got 1 for this, 1 for this, 1 for this, 1 for this, and 1 for this. How many is that? Yeah, it sits it right there. The answer is right there. Okay? You know, 5 big negative numbers, doesn't matter whether you multiply them or divide them. The signs, the rule for the signs doesn't care about whether you're multiplying or dividing. So you know it's going to be negative. You got an odd number of negative numbers multiplied and divided by in some order. Okay? So it's going to be negative, which means it's going to go down this way. Now we'll talk about all this a little bit more later. Okay? But that's the way it behaves. Now, the main thing I want to do right now is figure out to the left of -5 and to the right of 7. We just figured out that it's going to be positive to the right of 7, negative to the left of -5, right? Just by assuming you got a great big positive number or a great big negative number, then you know what the signs of all these things are going to be. Okay? And the other thing is, okay, Q of X can only change signs zeros in the numerator or the denominator. Okay? The only way you can change a sign is for one of these things to flip from positive to negative or negative to positive. If these things don't, if none of these change their sign, then the sign of this isn't going to change, right? You got 5 signs here. If 3 of them are positive and 2 of them are negative, then you've got a net positive, right? Okay? And unless one of these changes, until you get the value of x that changes one of these, that's what you're going to have. It's going to be positive, okay? Now if you get the value of x, like you're approaching x equals -2, so you go from a little to the left of -2 to a little to the right of -2, then x plus 2 is going to go from, what, negative to positive, won't it? So as you cross -2, x plus 2 flips its sign, which flips the sign of the whole thing. Okay? Make sense? Hopefully that makes sense. Okay, well, whether it makes sense or not, that's the rule. And you remember the rule and apply it better if it makes sense. So hopefully it makes sense, but that's the rule. Okay? Meaning that if this thing is positive somewhere between here and here, it's positive everywhere between here and here. Okay? Because it can't change sign unless it crosses the -2 or the 4. Okay? Until it crosses here or here. It's got to have the same sign all the way through here. Well, okay, that's good. What's its sign between here and here? To figure out what its sign is between these 2 points, all you got to do is plug one value between -2 and 4 into the thing and see what the sign is, right? Okay? So what's the sign, what's the easiest number between -2 and 4 to plug in? What's the easiest number you could possibly plug in? 0. If you plug in 0, you just get 5 times -4. Well, and you don't even have to multiply it out. You just want to know whether it's positive or negative, right? Okay? Well, that's going to be positive, that's going to be negative, that's going to be positive, that's going to be positive, that's going to be negative if x equals 0. I can say it. Okay? That's all. So it's positive. So it means that the function is positive all the way from -2 to 4. Okay? Now you actually want to calculate the y-intercept. And you can do that, 5 times 4 times 2 is 80, and that's going to be the 80. Where'd you get 80? 40. -40, right? And down here you have -21. Well, -40 over -21 is a little less than 2, right? So it's like you've got 1 here, 2 here, and the y-intercept is 40 over 21. Okay? So you know that your 0 here, your 4 here, the thing is probably going to do something pretty straightforward, like just rise up here, fall down here, reach a peak somewhere in between them, right? Okay? Okay, well, what we want to do is we want to analyze every interval. The interval from -infinity to -5, from -5 to -3, -3 to -2, -2 to 4, we just did, 4 to 7, and 7 to infinity, right? Well, we've done this interval, we've done this interval, and we've done this one, so we've only got a couple to go. But let's see how we would map this out. Okay, I'm going to stop the video here and go into the details in a minute.